All right, hi everyone. Welcome to today's webinar. And we'll get, thank you, Francisco. All right, so we've just started the webinar and we're waiting for perhaps a few more people to join on. But in the meantime, I'll give you a bit of a tour on what we're doing today. Okay, so first of all, this webinar is part of a very big series of webinars that we've done in the month of April. And yeah, it's this series, I think so far we've had 35 webinars in just over a month so far. And yeah, thank you very much for joining today. If you want to check out all of the webinars, they're on developers.rsk.co/webinars. And I've got a screen up here with that, so you can see all of our webinars, and you can also look at our past events. So all of our webinars, they're recorded and they get put on YouTube, so you can just click on the view recording button and you will see them there. Yeah, and a lot of them, they just have resources as well. For example, this one has slides and it also has a tutorial. There's some hands-on stuff as well. So yeah, a lot of material for everyone to go and check out. Yeah, and in case you're interested, those of you who are a little bit early saw me starting off the session with a screen recording thing here. You can read more about it here on this blog post that I have. So that's how I'm recording my screen. I'll paste the webinars link there as well for all of you to check out. Yeah. Okay, it looks like we got three more people just joined us. Yeah, I'll start with the presentation. Okay, so yeah, welcome to today's session. Today's topic is how to create your own non-fungible token on RSK using Truffle and OpenZeppelin. And we'll get into what all that means shortly. But first, a bit about myself. I'm Brendan. I'm a developer advocate at RSK. And a little bit about myself. I am a JavaScript and Node.js developer. Have been for quite a few years now. I blog on bguiz.com. This is my latest post. I also run a tech meetup in Singapore called the Decentralized Apps Development Club, or DApps Dev Club. And you can go check it out over here. These are all the past sessions that I've run last year. That was an in-person meetup. I don't think that's happening this year. Hi, Diego. So you can go check out all of these sessions. You might find some of it useful. Okay, cool. And I'm also currently learning Spanish. I'm on day 160 something at the moment. So if you talk at maybe half speed, I'll understand about half of what you say. That's where I'm at the moment. And I guess as of this week, I'm also a caterpillar farmer. To show you this that happened overnight last night. So these are lime butterflies, and I did this on a time lapse, and you can see that is a butterfly emerging, or eclosing, I should say, from its cocoon, a chrysalis. Sorry. Yeah. Okay. Yeah. All right. So what are we going to be doing in this session? So we'll be doing a bit of setup where we start a RSK node, and it'll be running a reg test on your own computer. And then later on, we'll also configure Truffle to connect to either the reg test node that you have set up on your own computer or a testnet node. Up to you. We'll do a bit of both, and it's up to you to decide which one you feel like doing, following along with in this session. Yeah, and then with Truffle, which is a smart contract. Yeah, and then with Truffle, which is a smart contract development tool, we'll be using Initialize, a new project. We'll be compiling some smart contracts, and we'll also be deploying them onto a blockchain using the migrate command. And finally, we will scaffold a front end using create React app, and then we'll also add some DAP functionality using Web3.js. Now, if we were to do everything here from scratch, it might be very difficult to complete on time. So there is some prerequisites which I hope you're able to meet. We'll go into them in a little bit of detail later on, but I won't be doing everything from scratch. Let's put it that way. So, for example, you'll need a browser that already has MetaMask installed, and it already has networks configured for to connect to RSK, both regtest and testnet. And in case you want to see like a webinar, like a demonstration, I guess, of how that works, you can find that and many more in our webinars page. Yeah. So we'll be breezing through the prerequisites part quite fast, and we will go straight to the part which is focused on the smart contract development. Okay, so first up, there's a hands-on session. This is a hands-on session, and I would like everyone to go to this URL. Before we do that, what I'm going to do is I'm just going to copy this URL over here and paste that in the session in the chat session. So that will give you the same set of slides as everyone else has got here, and also the link that we had just now. So this is a kind of a cheat sheet or a walkthrough. Every single command that you'll need to follow along to follow in today to complete today's session. And yeah, I guess let's begin. So this walkthrough here goes through all the details, and I have the same file over here. So I'll be using this instead because it's easier to navigate. And yeah, so let's begin. So I'll bring up my terminal over here. So one of the first things that you need is a Posix-Compliant Shell. So if you're on Mac or Linux, you can just use your standard terminal like what I'm doing right now. If you're on Windows, I suggest getting Git for Windows, which will install something called Git Bash, and that will give you a terminal which should work with most of the commands that you'll see today. Yeah. Next thing you'll need is Node. So if you do node-v, right, you should get version. You should see something essentially. I think the minimum version that you'll need for today's session is version 8. Yeah, I've got the version 14 at the moment. And if you don't have a version of Node, or you want to manage multiple versions of Node, I would strongly recommend this thing called NVM. And it's you can just find it on GitHub, and that essentially allows you to install and switch between multiple versions of Node. All right. The next thing that you'll need is Truffle project related tools. So we need Truffle. And we also need Truffle Flattener, and we'll also be using something called mnemonics. So I already have these installed, so this is going to be a redundant thing. But essentially, just npm install, and this flag is important, a global flag, meaning it gets installed at the system level rather than in the current directory, and then it'll go ahead and install, and it'll take I would say more than a minute if you didn't already have it installed. It's just gone a bit faster for me because I already had them on my machine. All right, next thing you'll need is Java. In order to run RSKJ, which is distributed as a Java archive or jar file, you'll need Java 8, and the version that you need is this. Right. Oh, I have 11 at the moment, which is a newer version. So I can just say that because I would recommend something called SDK-man to install and switch between multiple versions of Java. Works on most Unix systems. If you're on Windows, you'll need to just go to the Oracle website and download it and install it manually. I'm not aware of an alternative that's similar to this. Okay. So what am I doing now? Right. And I think it's SDK use Java sorry, I made a mistake. SDK list Java grep installed. Should have done this first. No, I don't have a version of Java installed. Okay. SDK list Java. SDK install Java. And I'm just going to pick this one. And so we'll just wait for that to install. Okay, so good thing I have a prerequisites thing here. And for those of you following along at home, hopefully got a bit of extra time to follow along as well. All right, and at the end of it, you should be able to run Java version and get an output that says Java version 1.8, which interestingly is Java 8. Yes, thank you, Francisco. So if you have any questions, feel free to put them inside the chat room, and I'll try to get to them as soon as I can. If you have any questions now, that would be a good time as well, because we're waiting on this. All right, I'm just opening up a new shell to do some more commands. Okay, so the other thing we're going to check is that we have curl. Right, so I have a version of curl installed, which is pretty important for this session. Okay, so then the other thing you'll need is any text editor that you like, but preferably something that has syntax highlighting for Solidity and JavaScript, which we'll be using today. Visual Studio Code is a very good IDE or code editor for that. So yeah, if you don't have one, get that. Okay, cool. So the next thing is that we'll get RSKJ running locally, and that will provide you with a localhost only network. What that means is that you have a version of RSKJ running on your own computer, and it'll allow you to interact with the blockchain much faster, because the blockchain isn't in a public network, and it doesn't require multiple computers to agree on something before a block is added. It's just your own computer doing stuff. Wow, this installer is taking a very long time. I think I might already have RSKJ running, and I will verify that in another terminal. So let's see. Okay, sorry, I have it somewhere else. Let's see if I actually already have it running. Not off to a good start here with the live demo. All right, I do indeed have RSKJ running in regtest somewhere else on my computer. Thankfully, before somehow my Java installation got wonky, but all good. Okay, so this command hasn't failed, and basically what I'm asking is I'm sending a request to RSKJ. I'm saying, what is your block number? And this is a JSON RPC request that is actually identical in terms of protocol to the one that Ethereum uses. So it's compatible at that protocol or communications layer. And this is the response that I get back. So it's saying that the result of the query is this, and that's a hexadecimal number. My terminal just converts it automatically. So 2711F in hexadecimal is 160,031. So that's how many blocks I have in my regtest blockchain that I have running locally. Cool. Okay, so now I'm going to do the same thing, but this time I'm not going to connect to my own computer, right, my own regtest, but I'm instead going to be connecting to a public node. There we go. So we get a different result for more or less the same query. So you'll notice that I have a different URL. Instead of pointing to localhost, I have this address, which is the RSK testnet's public node, and it is exposing a JSON RPC endpoint. And you can actually take a look at the full thing over here in, let's see, RSK network. So if you go to stats.testnet.rsk.co, just going to paste that over here. You can take a look at the status. So you can see here I've got 828,000 blocks. And if you see here, I've got 820 blocks. And if you see here, I've got 828,481. So I'm one behind. It's probably just happened. And there you go. Now I'm on par. Oh, okay, so this one's one up again. But you can see it's more or less keeping in sync with each other. Okay, cool. So if the first command where you query localhost, if it fails, that means that you are not yet running your regtest instance. And if this command fails for whatever reason, it probably means that you have like some sort of network proxy or some other layer in your network stack is blocking the access to this thing. So check that your port numbers are not blocked. There aren't any domain blacklists or anything like that. Okay, so we just saw this, right? So this number over here should match what you see over here, and then you know that you're connecting properly. Okay, so the next thing that we're going to do is we're going to initialize a new Git repository. So you'll see here that I made a new directory called this long string workshop RSK ERC721 token with OpenZeppelin Truffle, blah blah. Okay, so I've already done that. What I'm going to do next is I am going to do a git init, and then I'm going to say git remote add origin, and you don't actually need to do this to follow along. What I'm going to do is I'm going to copy this and go to GitHub. Right, and new repository, paste that there. And the reason I'm doing this is so that everyone can follow along live as I go along. So then I'm gonna just copy those commands, paste it there. Cool. Nope. That didn't work. Git remote -v. All right. Aha, because I have no commits yet. Okay, that's cool. That's cool. Right, so I'm going to do Truffle init. And so recall earlier on I installed Truffle. So one of the things that does is if I just type the word Truffle like halfway through and I hit tab, I should be able to find it on my path. And you can see where it's been installed. So if I do which Truffle, I get that output. So it's sitting somewhere in my system, right? And it's accessible on the command line. So I'm just going to say Truffle init, and that will generate an empty project. Okay, so I just hit Y and press enter because I'm already inside a directory and there's some files in it because I did a git init. And then I'm going to do git add. All right, before I do that, git tree -i node modules. All right, so we can see what Truffle has done over here is generated a contracts folder. It contains migrations.sol, one migrations file, an empty test folder, and a Truffle config file. Now, we'll get into what all of that is later on, but for now, we're just gonna do this, right? Actually, I realized that the text in my terminal is slightly too small, so I'm going to bump the size up a little bit so that it looks clearer on the video. Okay, maybe one size bigger. All right, excellent. Okay, hopefully that's big enough for everyone watching or following along on the video. Okay, so so what I'm gonna do now is do my first commit, right? And then I'm gonna do git push origin master. And this time I should actually see this repo come alive. Yep, it's working now. And so I should see this, right? I'm gonna paste that link into the chat. There you go. So for those of you following along, you can go to that repo and you can click on this button over here that says clone or download, copy this, and you can do git clone and paste that, and then you'll get exactly what I have done. So get exactly what I have done so far. And every time I push, then you'll just have to do a git pull, and you will get the steps as I'm following along. So that's another way in which you can follow along in today's webinar. All right. Yeah, okay, cool. So what I'm gonna do next is initialize an Npm project. So npm init. I'm gonna accept that. And for a description, I'm gonna go with, let's see, what do I have here? Yep, that should do. Yep, all the defaults. Truffle, RSK, open, Zeppelin, workshop. Okay. Okay, we've got a new npm file, and so I'm just going to do this. All right. We also want to create a git ignore file, so I'm going to do sorry, no, modules, because we don't want to commit that. All right. Okay, we've done this already. We've inspected the directory structure, and that's generated by Truffle, Truffle init, sorry. Right. Next thing is that we need to install any local dependencies for Truffle. So I'm just going to go ahead and copy that. And while it's going in the background, because this might take a while, I'll just explain what it is. So first up, Open Zeppelin contracts. This package here is a set of Solidity smart contracts that have been audited. So what that means is that a lot of people check them to see whether there are any errors, whether there are any potential exploits, and it contains a bunch of, I would say, well-known or common use cases for smart contracts, such as tokens, such as the one that we will be using today for ERC 721. More on that later. And yeah, when you develop against a Open Zeppelin smart contract or any other audited smart contract, you have a bit more confidence that the code is you have a bit more confidence that the code is bug free, because they've gone to all that trouble. Okay, and the other thing that we've installed is this thing called a HD wallet provider. HD stands for hierarchically deterministic, and is it's something to do where you have a certain passphrase with 12 words or more, and you use just from the dictionary, you select it at random, and you use that to generate enough entropy to create multiple wallets in a hierarchy. I won't go into that much detail, but we are going to be using one of these wallets. And if you've ever used something like MetaMask or any most wallets, they have this seed phrase option. That's usually based on a hierarchically deterministic wallet implementation. So we're going to use one of those that Truffle gives us. Okay, so let's see what that command, that npm install command did. So it actually just added a couple of dependencies to our package.json, which we'll accept. Now the next thing we're going to do is just do that so that people following along can see that happen. So you'll see over here that my last commit was that's available was a few minutes ago. Now if I refresh this page, you'll see that I just have had one about 15 seconds ago. So you'll see each time I push, this gets updated. So now if you do a git pull origin master like this, for anyone following along, you should get my latest changes. So that's one way you can follow along. The other way is to actually do all the steps that I am doing on screen right now. So I'm presenting either option. Please do not try to mix and match both, because then you'll get into a strange state and you'll get some git conflicts. So just pick one approach and follow that. Okay, cool. Right. Now, the next thing that we'll be doing is initializing a React application. Let's just skip ahead. Right. Okay. Create a React application. So what npx does is it is kind of a shortcut. What it does is that there is this npm dependency with this name, and what it does is it does a sort of global install and then immediately runs the main binary or executable that is exposed by that by this particular thing. So it's like kind of like a one-liner way of doing npm install -g, create React app with this version, and then running create React app. Yeah. So we'll just wait for that to finish. It does tend to take several minutes because it pulls in a lot of packages, and it might take slightly longer if you haven't installed this particular dependencies before, because npm has some caching of its packages. Okay, so I've installed, downloaded the dependencies, and now it's sort of running through their install scripts. Should just be a few more seconds. All right, all good. All right, so now we should have an app folder, right? And that app folder will have a ton of things inside of it, but the main, but we're mostly concerned with this src folder, which contains the code that runs our front end. And create React app, in case you didn't see the output from earlier on, basically allows you to develop an application in React, and it scaffolds all the boilerplate stuff for you. So now if we go into the app directory, we can do npm run, npm start, or all of these other commands to just run these various things. And we'll be making use of that later, but not now. Okay, so for those following along, just going to do that. And next up, we have installation of local dependencies on the front end. So I'm going to do cd app, and inside there, I'm going to install these dependencies. Okay, so Web3 gives us Web3.js, and that allows us to interact with from a front-end point of view. It allows us to interact with an injected Web3 provider, which is good, which allows us to interact with something like MetaMask. And Bootstrap just gives us some built-in CSS styles to make our web page look a little bit pretty. Okay, so that's finished. All right, and just point of note: every time I install something, I'm specifying the exact version using the @ symbol followed by the version number, and what that means is that I have I will only ever install this particular version. So if Web3 decides to release 1.2.8, I won't get that. If Web3 decides to release Web3 2.0.0, which is actually possible because the beta is already out, then this tutorial might stop working, right? So that's if I've just done install Web3. The other thing I've done is npm install save exact, so the package JSON will also save the exact version rather than a Senver loose match type version. And we'll see exactly what that means when I do this, right? So we'll see what is being added. So you can see over here, Web3 is added, and it doesn't have the caret symbol in front of it like that, which means that only this exact version can be installed. Same thing goes for Bootstrap. I didn't get caret 441. All right, so we'll accept that and then commit for those who are following along via Git. All right, so this part is where we get to use the hierarchically deterministic wallet that we mentioned earlier on. Before I forget. All right, so that we mentioned earlier on. Before I forget. All right, so there's something called a bit39 mnemonic, and what that gives you is a 12-word passphrase. We're not going to actually use this website today, but it's a good resource to learn about it. So what you can do is you can say enter a bit39 mnemonic or generate a random new one. So you just put in 12 and press generate, and then it just takes an English dictionary by default and selects 12 random words from it, and then you can see all of that. So let's select Ethereum, right? You can skip all of that, and then it has something called a derivation path, which we're not going to go into detail with later, but that's essentially what the value of the derivation path is. And then you go down and you can see, hey, from those 12 words, right, I have managed to generate all of these things over here. I've got an account at index 0, which has this address and this public key and this private key. And so that in itself is a wallet, but I haven't got one wallet, but I've got like a seemingly endless number of wallets. Each time you increase this index number here, you get a new wallet. Right, and that's what bit39 gives you, and that's essentially why it's called hierarchically deterministic. Because if you have this derivation path and the 12-word mnemonic, right, you can deterministically regenerate the address, the public key, and the private key for any of the wallets that, or I should say, accounts that are necessary. Okay. So that's like a whirlwind tour of bit39. We're not going to actually go into the details, but instead of doing that, what we'll do is we'll just say mnemonics, and I'll just paste that here so you can see what's happening. Mnemonics just generates a 12-word phrase, right? So what we're going to do is redirect the output of mnemonics to a file called .secret. And for those following along, I'm going to do something that I would consider to be an anti-pattern. I'm actually committing my secret into a repo. Now, you should never do this for obvious reasons. But I'll spell it out anyway. Anyone who has these 12 words is able to operate wallets as if they were you. So essentially, they have your private keys, and this is a demo, so who cares, right? But if you actually have some real cryptocurrency in it, or you're deploying a real contract from any accounts controlled by this, you should never do that. You should never reveal this to anyone. Yeah, so with that disclaimer out of the way, let's go on to gas price. Okay, so recall earlier on I did a curl command to get the block number for testnet on regtest. Well, we're going to do the same thing, but this time it's slightly different. We're going to use it to get the gas price. Whoops, shouldn't have double clicked apparently. Okay. So what I'm going to do is just run that command, and you can see here the response is I've got that, and what that means is that I had the gas price is 60 million, which is actually 60 million times 10 to the power minus 18, which is a fraction of a RBTC, a unit of the cryptocurrency. So we and what that is it's the amount that you have to pay per tiniest unit of computation to compensate the miners for their CPU costs or their storage costs. So we're going to run the same command again, but this time we're going to redirect it to .gas price testnet.json. Alright, cool. And for the purposes of anyone following along at home, that's been git committed. Alright. Alright, so now we're finally going to actually write some code inside our project. So I'll just bring this file over here. Now, this is the folder that we've been working on, and I'm going to open up Truffle config over here. And what I'm going to do is replace this top part here with this bit over here. I'm not going to type it all out because we won't have enough time. Okay, and I'll make it slightly bigger so that everyone can see. Maybe turn on wrap. Okay, so HD Wallet Provider, as mentioned before, is it's a node package, and it gives you the ability to read in to use an input mnemonic string, the 12-word phrase that you see earlier on, and it'll generate a entire list of addresses for you, as we saw in the website earlier on. What we're doing here is we're reading in the secret file, which we've saved earlier on. So this file, we saved it earlier on. We're just reading it in and then parsing it and making sure that there actually are 12 words in it. The other thing that we're doing is we're opening up the gas price JSON file that we saved earlier on. So this is just the JSON response that we got earlier on, and this is 60 million. So we're reading that in and parsing the result, the hexadecimal result, into a number, and then we're saying we're throwing an error if we aren't able to read it. And then after that, we're doing a console log, which means, hey, let's just see that we'll just like get some feedback as to whether it ran correctly. Okay. So we'll test whether that worked by just simply running truffle console. It can be any other truffle command really. There we go, it worked. And we get this error which we're expecting because we haven't really configured a network yet. So it's trying to say, hey, I'm trying to connect to this. So it's trying to say, hey, I'm trying to connect to this default network, but it's not working. So we can ignore that for now. What we really care about is that this error and this error did not get thrown, and instead we got the gas price and the mnemonic printed out as expected. Okay, cool. Let's move on. Right. Yeah, so we're just confirming that we do indeed want to add this. Cool. And we're gonna do excellent. Okay, the next thing we're going to do is specify the compiler version. So by default, Solidity Truffle uses a particular version of Solidity, and we want to lock it down to this particular version. It can be anything like this. You could also specify that, but we just want to make sure for this demo we're using this version. Yeah. Okay, so we'll add the Truffle config again. You can see that's one change, and a small little change. We'll commit that as well. Okay. So by default, Truffle expects to find a thing to put its files inside. So whenever it runs the compiler, it expects that. But we actually want to put it inside the apps folder, the app folder. Right? We want to put it inside here so that this file over here is able to access it. So this is where we're going to create a React application, and so it's just going to look for contracts within the same folder that it is inside of. So we're going to do a custom contracts build directory over here. Right, and let's do that. Yep, and cool. All right, so I'm just going to run Truffle console again just to make sure that I haven't introduced any silly errors. Okay, looks like it paused okay. Okay, so now the next thing we're going to do is use Truffle to to connect to the the RSK testnet. I'm just going to copy and paste this snippet over here. So you can see all of this stuff on the networks. It's Truffle is originally created for use with Ethereum, and basically, if you want to connect to, I guess, commonly or well-known Ethereum networks, you just got to uncomment one of these ones. But for now, we're connecting to the RSK public testnet. So we're going to use a HD wallet provider that is pointed at this JSON RPC endpoint, and we are going to use the 12-word mnemonic that we generated earlier on. The network ID is 31. 31 is just the RSK testnet network ID, and it's important because that is used to determine the checksums of addresses and so on in RSK. The gas price that we read earlier on is stored inside this variable. What we're doing is we're just making it say, hey, I'm going to use 110% of the gas that was specified as a minimum required by the network. So the network is saying, hey, I need 60 million Wei as the gas price, and we're going to say, okay, we'll use 66 million then. And this just specifies a timeout. How long are we allowed to wait for the network to get connected? Okay, so I'm just going to do the usual. Yep. And then I will commit that. Actually, before that, I'm going to attempt to connect to the testnet. So previously, we just did Truffle console, but this time we're specifying, hey, I want to connect to testnet, and then that means you'll look under this this particular configuration value. And it looks like we've succeeded because now we've got this prompt. And you'll notice that my prompt previously was this, right? This long thing. So it showed my username, my computer name, and the folder that I'm within. But this time it's giving me a different prompt. So I'm in a different shell. I'm in a shell within a shell, if you will. And this is a read evaluate print loop. Not too dissimilar to the Node.js read evaluate print loop or REPL. And it tells you, hey, this is Truffle, and it tells you, hey, this is Truffle, and I have testnet. And you'll notice that you have Web3, already accessible. So it's like the Node.js REPL, but it's got a bunch of Web3 things sort of built in or baked into it. Okay, so I'm just going to verify that I'm able to connect to this network properly. So I'm going to get the block number. So remember the curl command that we did earlier on with we said eth_block number in the JSON RPC thing. Yeah. So this is the Web3.js equivalent of doing that, right? So we can do Web3, and you just type, there's autocomplete. So you can do web tab, Web3, then eth.get b, let's just say, and then you hit tab a couple of times, and then you get a few suggestions. So I'm going to do get block number, right? And you can just do like that, and that is the API for it. And we know that we have to do an await, right? And this will return a number. Okay, so. And this number should increase every 30 seconds or so, because that's how often a block is added on the testnet on average. Okay, then the other thing that we're going to do to verify that we're actually connected to the testnet as opposed to any other RSK network is to get the network ID, which is 31, matches this one over here, and we're happy. Okay, so let's exit. So you'll see that I dropped out of the Truffle REPL and I went back into my standard system shell, which I've got over here. Okay, so I'm gonna, let's see. Right, so I've already got Truffle config added, so I'm just gonna do a commit for those following along at home. All right, so the next thing we want to do is we want to get a list of accounts and save it into this file just for our own reference for later use. So I'm gonna jump back into the Truffle console, connect to testnet again, and this time I'm gonna do something different, right? I'm gonna also do this, and so you can see what I've done here is got accounts. I've saved the value of this and sort of just stripped it such that I only get the keys, and then I've saved that in a variable called account. So now I have a list of 10 accounts. That's the address of account 0, account 1, so on and so forth. Yeah, and these are all generated from the BIP39 mnemonic by Truffle's HD wallet provider. Okay, but before we quit this this REPL again, I'm going to do this, and it simply writes that out to a file, right, called accounts.accounts testnet. Okay, now we're ready to exit, and just so that we can see what's going on, I'm going to do, right, so we've got our file written onto disk, right? You can see that file is sorry, forgot the A. All right, there we go. Accounts testnet. It's written to file disk, and we just saw that we got the list of accounts. All right, cool. All right, so so now that we've done that, what we want to do is we want to go to the RSK testnet and fund an address. So what I'm going to do is I'm going to get this address over here, and I'm going to copy it, and then I'm going to jump over to a browser, and I've got RSK's testnet faucet. I'm going to paste that address there, and I can't tell if that's a capital W, so I'm just going to refresh. I hate characters, Latin characters that are ambiguous between lowercase and uppercase. Yeah, I'm never sure if the site takes that into account or not. Anyway, I'm going to paste this link back into our chat here. So if you go to faucet.rsk.co, that gives you some testnet RPTCs. Yeah, and we'll just have to wait for about 30 seconds for that to be mined. And once it's mined, it should show. It should display something that shows us the transaction in which that was sent to us. All right, now we can go to RSK testnet and we can see that the next block is almost about to be mined. probably at the 33-second mark. Sometimes it can go a bit over. Okay, it's going to orange territory. Taking slightly longer than usual, this one. Hopefully we made it to this particular block. Okay, we did. So you can see this address over here that I have over here, F18BA. That's the address that it got sent to, and we can go to the transaction hash. This is the testnet block explorer, so we can see any address, any block, any transaction, so on and so forth. So we can see from this is the address of the faucets, probably smart contract, and this is the to address, which is our address that we just generated, and now we've got a value of 0.05 RBTC. Yeah, and that's all we really need to know. And now we're just going to, let's see, yeah, connect to the testnet, Truffle testnet again, and we're gonna say, hey, let's see, this account over here. Alright, so we got that guy. Aha, okay, so yeah, I've done it slightly differently. Oops. Yeah, so we've got this very large number starting with 5, and you can see over here it's 3, 6, 9, 8, sorry, 12, 15, and 18 over here, which would be past this point, would be a full RBTC. So it's like 0.05 RBTC. There are 18 decimal places, and this is the number of the smallest unit. So that's why it looks like a really big number, even though it's only 0.05. Okay. Okay, so I think we're happy now with the RSK testnet. Now we're going to configure a reg test connection. So this is a completely different network. And this network is running on your own computer. It's much faster. So we'll copy that and add that over here. So this is reg test, and we're going to do a network ID of 33 this time. And 33 is simply a different chain ID from the RSK testnet, just to make it different. And instead of connecting via HD wallet provider, we're just going to be connecting to host and port. And reg test is a special case. By default, when it starts up, it starts with all of the accounts that are in it unlocked, so we can access them and use them without actually having to manage any of the keys in the application being that's calling them. So it's essentially a free-for-all. Anyone who is able to access localhost quadruple 4, and talk to the JSON RPC has full access to these accounts, which is fine because it's reg test, right? This is inconsequential. Okay, it's not any real amounts are involved. Okay, so what do we do next? So this time we're going to do a Truffle console as well, but instead of testnet, we're going to do reg test, right? And this maps to this string over here. All right, we're connected. You notice it's slightly snappier than before. And I'm going to do the same things as before. Okay, so you can see that we've got a block number that is significantly different from the one that we got on testnet, and a network ID that is 33 instead of 31. So I'm happy with that. We're going to just that. Okay, and do a commit and push for anyone following along at home via the Git repo. I'm just going to check in on here and see if anyone's got any questions. So far, so good. I hope that means that I'm clear enough. Okay, and now we've finished setting up our project. We've finally got to the part that we're going to start writing some code, right? But what I'm gonna do, in addition to what's on the contract, before we continue, is to actually copy an additional piece of Truffle config. So I actually have a testnet instance that is running locally, and because demo gods are, generally speaking, not very cool. They like to mess up when you're on the spot, when you're doing something live. So instead of talking to the RSK public network public node, I'm going to be talking to the same testnet, right? You can see the network ID is the same, except that I'm going to be connecting to my own computer just on a different port, right? And everything else about the config is the same. So I'm using the same mnemonic, so therefore same set of wallets or addresses, same network ID, same gas price, and I'm giving it a slightly smaller network check timeout because it's on my own computer, so it should be faster. So I'm gonna test that as well before we continue. All right, excellent. So let's see. I'm gonna go back to all right. So I want to see what the block number is here, right? And you can see it's 828.548.48. I'll go back to the testnet faucet. Okay, thanks, Fox. White background in terminal VS Code. Ah, I see. Yeah, I'm a fan of the dark theme. Hard to change my ways, but to each his own. Yeah. Okay, so let's see what's next. Okay, 828.548, and then we can take a look at RSK testnet stats. Sorry, 828.549. So we can see it's just one behind. Now it's caught up. So you can see that even though I have connected to a different computer, I haven't connected to the public node because it's a blockchain and they all propagate the same set of blocks to each other. They're kept in sync that way. Yeah. I mean, there are many other ways to verify it. This is sort of a litmus test, if you will. It's not really a proper test of the fact that of the blocks being in sync. Okay, cool. Now I'm gonna do .exit to quit that. Okay, let's see. Done all of that and done all of that. Okay, we're gonna start with smart contracts now. So we're going to use the Truffle flattener tool. So that should have been installed right at the beginning. Truffle-flattener, right, like that. We're going to be using that. And earlier on, we also installed OpenZeppelin. So what I'm going to do is open up this file over here, just so that you can see, take a look at what we're doing. Right? So that fires it up inside of VS Code, and this isn't code that we have written, right? This is code written by the OpenZeppelin, and they've published it under this npm package, and we've just simply installed it as a dependency. And you can see here that ERC721 full requires or imports a bunch of other Solidity files, and then it extends them. So this is the main implement. I guess that is a unit of exchange, and a fungible token is something that is divisible, and each unit of it is equivalent to any other unit of the same token. Whereas a non-fungible token, each token is unique, and they are not necessarily equivalent to each other. They are, by definition, each one is different and could therefore have a different value, so on and so forth. So a great analogy is cash, right? If I have a $5 note and I give you a $5 note and you give me another $5 note, that makes zero net difference. It doesn't matter which note I had. So that's an example of a fungible token in real life. A non-fungible token is, let's say I use $5 to buy a couple of apples, right? And these apples are special to me. They're one of a kind. I can't give those, like if I swap my apple with your apple, right? They aren't necessarily or by definition the same, right? You might treat them the same, you might treat them as the same thing, but you might say, oh wait, this apple is different. Maybe I should have picked a different example than apples, but I went with $5. So, maybe you should have gone with $100 bill and therefore being able to buy something that is slightly rare. Okay, note to self for next time. Anyway, we've taken a look at this contract, and I'd strongly encourage you to look at the implementation of how this smart contract looks like on the inside, and also to take a look at this URL over here. The EIP 721. Oh, side note, EIP and ERC are used interchangeably, just in case that's you've heard both terms. The ERC is Ethereum request for what's it? I'm blanking. Sorry. And EIP stands request for comment. Yes. And EIP stands for Ethereum Improvement Proposal, and yeah, they're all stored on this website, and some of them have become extremely popular. Just a couple of weeks ago, we did a webinar for a fungible token, which is ERC 2020, and right now you're looking at the non-fungible token standard ERC 721. Not all of these ERCs or EIPs are for tokens. Some of them are for other things, like for example, improving protocol layer, or changing network, the way the networks connect to each other, or that sort of thing. So it's varied. Anyway, back to this. So this is our target file, and what we want to do is we want to take this file and any file that it imports and any file that those files import, because you can see that this file also imports other files, and just traverse the entire tree down all the way down to the last leaf imports, if you will, and get every single one of them and put them into a single file, right? You don't have to do this, but it's kind of one of the common things to do if you were to deploy a smart contract that is not and you're not using Truffle to deploy it for some reason. So let's say you want to deploy this via Truffle console or via a direct JSON RPC call. You would want to flatten your smart contract before doing so. So let's just do that, right? And then what I'm going to do is I'm going to open up this file that I've just done, and you'll see open in Visual Studio Code, so you can see, hey, it's concatenated all these files. I've got this file, which I haven't even seen before, right? But it is somewhere inside this thing. And then I've also got ERC ERC 165, likewise, so on and so forth. And if you scroll down far somewhere along this file, you will find ERC 721 full, right? So let's just go ahead and do that. So you can see almost right at the end of the file, I've got this ERC 721 required. So what I'm going to do is I'm just going to add that for those following along. And now we're ready to create our own smart contract. So this file over here is a smart contract that gives you an almost complete implementation of a non-fungible token created by OpenZeppelin. But we want to extend that to do something that is specific, like what makes our non-fungible token different, right? Right now we've just got this abstract idea of one. Yeah. So what I'm going to do is I'm going to create colors.sol inside of contracts. And then I'm going to just create this file. Now, there is a webinar that we've run recently called Inside Solidity, which goes into a lot of detail as to what, like the Solidity syntax, how to use the Solidity compiler, so on and so forth. And I'd strongly encourage you to check that out. It's in RSK, developers.rsk.co/webinars. The link has already been pasted in the chat group. But for now, we're just going to skip over all of that and just jump into the juicy bits, if you will. What this colors contract does is it inherits or extends ERC 721 full, which we got from OpenZeppelin and flattened earlier on. And then what we're doing in the constructor, right, is to say, hey, I'm going to instantiate this smart contracts constructor. I'm going to call it this smart contracts constructor with these two parameters. So I have then its name is color and its token symbol is this, right? You can choose anything you want. These are just arbitrary, but we'll see that later on in the block explorer. That's pretty much the only place where it, I guess, matters. And then we're also going to implement a mint function, which takes in 3 bytes, 3 hexadecimal numbers, and that is supposed to represent a color, right? And it'll check that this color doesn't already exist. So one of the rules that are implemented by this smart contract is that we're not allowed to duplicate colors, right? So if someone has got this particular shade of red, then no one else can have that particular shade of red. That's essentially the rule. And that gives this particular non-fungible token value, because then if you own that color and someone else wants that color, then they'll have to trade you for it somehow. Okay, so we've got a mint function that stipulates this rule, and anyone can call it, and it's free. Usually that's not true. Sometimes you have an additional require statement that checks that only the token owner can mint it, or anyone can mint it, but they have to pay the smart contract a certain amount of currency, so on and so forth. But in this case, this is just a demo, so we only have a single require statement, and then we're gonna say, okay, we're gonna create a new color and add that onto this array, and then we're gonna call _mint, which is separate from mint, and that is something that exists in ERC 721 full implementation from OpenZeppelin under the hood, right? And that does all of the stuff required to make it compatible with this ERC 721 token. Message.sender is whoever sent this transaction, right? So the address of who sent this transaction, so it knows who now owns this particular color non-fungible token, and the ID is just an incrementing number. Each time you push to an array, you get a number with that increases by 1, right? And then just to make sure that no one is able to I guess create a duplicate color, we just update this mapping over here, that this color is now set to true. So therefore, when the next person comes along and tries to mint it again, this will fail if the color already exists. So like I said, I'm not going to be going into too much detail on the syntax of the smart contract or Solidity in general. Please check out our previous webinars. The title of it is Inside Solidity, and we'll get a lot more detail on that. Right now, I've just described what the smart contract does. Okay. So I'm going to add this smart contract, and then I'm also going to do a commit for those who are following along. Now, what I'm going to do next is slightly different, right? I'm going to be looking at this. We don't have a build folder yet. Okay, so these Solidity files, they're actually going to be compiled and put inside a build folder, right? And Truffle is going to manage this. So if I do Truffle compile, this should be quite fast because everything happens locally on your computer. And now you'll notice that within the apps folder, source, contracts, I have a whole ton of JSON files now, right? So everything that's inside ERC721 full, that flattened file, every single one of those Solidity things got, those smart contracts got compiled, and each one got their own JSON file. And we don't really care about all of them. The main one that we care about is this guy, this colors.json. So, wow, okay. I think I'll have to turn off word wrap on this file. Okay, yep. So we'll just collapse all of the stuff, right? And right. Okay, so what are the important things? The important things are bytecode. This is what this particular colors smart contract compiled to. Now this looks really small, a simple smart contract, but it actually is quite complex because this smart contract has a lot of stuff in it, right? And I'm not going to do this now, but this bytecode is actually over 20 kilobytes. It's a fairly large smart contract. Yeah, so it's pretty complex. Now the next thing that we're going to be doing is to take a look at networks. Now we haven't deployed the smart contract anywhere. It only exists on disk on our computer. It hasn't been deployed to either regtest or testnet at the moment. So we're expecting this network to be empty, right, at the moment. And we'll see that fill up later on when we do a deployment. So I'm just going to commit that for those who are following along. Right. Okay. So those following along can do a git pull, and you should be able to get these files. Now, these probably these files will probably be the same as if you ran them yourself, especially if you have the same version of Solidity. The thing that I'm expecting to be different is this updated at thing, which will basically be, you know, whatever timestamp that you happen to run your Truffle commands at. Okay, yeah. Okay, so the next thing is we're going to deploy this smart contract onto a blockchain. Now let's do this. So we'll create a migrations file, and let's collapse this. Don't need that at the moment, and we'll open up migrations, and you'll see there's an initial migration, and we've also got this new one over here. I'm also going to open up the initial migration, copy the whole thing, paste it over here, and I'm going to replace all instances of with colors to match colors.so, right? So now we just it's doing nothing fancy. It's just saying, hey, I'm gonna grab this colors.json file, because that's what this artifact thing that's injected by Truffle does, and then I'm going to say deploy, and this is another thing that's injected by Truffle. Cool. Let's give that a whirl for the benefit of those following along at home. All right, so I'm going to do this command, and you'll notice that I have this time thing at the beginning. That's actually optional. You can just do Truffle migrate network regtest, and what that does is it tells Truffle to take a look at the Truffle config JSON, the network's key, and inside the network's key it looks for regtest and use that configuration, as we saw earlier on when you use Truffle console. But instead of just firing up a read evaluate print loop, it attempts to do migrations, which sends some transactions to the blockchain, and these particular transactions, they deploy the migration smart contract, which is auto-generated by Truffle and you don't really need to care about, and also the color smart contract, which is the main one that we care about. And the main thing that we care about now is the smart contract address. So when we want to interact with the smart contract, we need to care about this particular address. Now, yep, so all looks pretty much the same as this. And let's see, it took approximately 13 seconds to complete the deployment. So that's good, fairly snappy. And if we, at any point in time, we forget what address it was deployed to for reg test, we can always do this, and that's the smart contract address for colors. Now, I'm gonna do this, right? And while we do that, we'll actually see, hey, there is a difference, right? In the smart contract, this networks is no longer empty. So let's open up colors.json, collapse all of these things. And previously, you'll notice that networks was an empty object, but now we've got this new object called with the key 33. That's the network ID for reg test, and it has all of this stuff in it. The thing that we're most concerned with is this address, right? That's the smart contract address that we've deployed to. Okay, so yes. Yes, and then we can commit that for the purposes of those following along at home. Now we're going to do the same thing for testnet now. Right, this is probably going to take way too long. So what I'm going to do is I can't remember the name that I gave it. Go to migrations, truffle config. Local testnet. Okay, so now I'm going to be connecting to the RSK public testnet, but via a node that's running on my own computer, right? And this I'm expecting to take much longer. The best case scenario, because the migration step for Truffle, it actually involves 4 transactions in total. So, and they have to be run in sequence. So that happens across 4 separate blocks, and each block taking about 30 seconds to mine. In the average scenario, that will mean that our best case is about 2 minutes and 10 seconds. 2 minutes plus. But in practice, transactions don't always get mined in the first block that they attempt to get included in. So sometimes you get included in the next block and so on. So I'm expecting this to take about 3 to 4 minutes to complete. While we're waiting for that, let's go back to our slides, right? So I'll talk a bit about RSK networks while we're waiting for that. So RSK has 3 networks, and today we'll only see 2 of them. One is the reg test, which is the one that we deployed to earlier on. It's localhost and it's on your computer only, and it's really good for fast development or iteration cycles. So you deploy fast, transactions are fast. You don't really have to wait for blocks; they're instantaneous. You only really have to wait for the fact that every transaction needs a JSON RPC request. So there's some network time involved. Testnet is a public network, right? Meaning it is a real blockchain deployed across multiple computers, and they have to all come to a consensus. The miners there are real, running real computers that are mining your transactions, adding them to blocks, so on and so forth. However, it is fake. You would consider it to be fake, quote unquote, because the currency that's on it and the data that's on it is generally speaking not worth anything. So essentially, this is a step in between reg test and mainnet. So you want to deploy to a real network and experience a real network type environment. That's when you use the testnet. and you can access it through the public network, or you can do it what I have done locally, which is to connect to a copy of the testnet node that you're running on your own computer. And the third and final one is the RSK mainnet. It is also a public network, but it is real. So any currency that's on it, right, actually is worth something. Any tokens that are on it are typically worth something. You don't want to do the stuff that I've done in this tutorial on the RSK mainnet, and that's because if you do it on the mainnet, you're almost guaranteed for someone to steal your tokens or to steal your currency at whatever address you've exposed. So your .secret file, your mnemonic, please do not reveal that to anyone if you intend to use it on the mainnet. There's a whole bunch of other precautions that you should take while doing so. Okay, and it looks like this time our deployment has succeeded, and it's taken us 3 minutes and 22 seconds. So it's about 3 minutes longer to complete. Took about 3 minutes longer to complete than the first than the previous one that we did, which was about 12 seconds. That's a difference between a quote-unquote real blockchain and a localhost only simulated blockchain. That what Regtest is. Cool. Yeah. Thanks. So I'm guessing that this was 20 minutes ago. Yeah. So EIP stands for Ethereum Improvement Proposal. ERC stands for Ethereum Request for Comments. All right. Let's continue with the. Smaller. Okay. So we'll get that output. Yep. Pretty similar. Right. Now what are we going to do? Before we'll just check what our token address is. So it's output over here under contract address, starting with 6003, and here we can see it as well. And if you want to, you can always take a look inside your colors.json file and see the same thing. Yeah. So I'm going to accept that. You can see the address over here too. Yes. And then we're going to do a git commit. So for those of you following along, you can just pull that from your git repo, pull origin master, and you should get that. Okay, now we've finally got to the front end, which is the probably the most involved or difficult part of this demo. In light of time, I am going to breeze through this without explaining much. Yeah, so this stuff is just very quickly changing a few things that are required for, let's find title. So I'm just replacing the title, replacing the default. We also want to open up the index.js file, and inside of that we want to replace the built-in one with something from Bootstrap. So anyway, we've got a couple of utility functions. Save that. Yep. Cool. And you can do that for those following along. Okay, now we'll need to define the main app component. So this is pretty much a very, I guess, pointless component because it does nothing. It doesn't even have a render function. But what we're doing that's significant here is to set up its initial state, to define what are the things that we will be manipulating, if you will, or displaying or tracking inside our front end for this application. So that's your address. The contract will be initialized later, so on and so forth, and the colors. Okay, total supply is the total number of tokens. Okay, so we'll save that. Yep. And then we'll do a commit. Okay. Now the next thing we'll do is to so inside the, I guess, initialization function, if you will, we need load web3 and load blockchain data. So I'm just going to go ahead and copy that. This particular function is actually boilerplate code. You'll need it in anything that makes use of web3 in a DM. Basically, MetaMask injects, depending on its version, something called window.ethereum into the browser, or if it's an older version, window.web3, and in either of those cases we have some code that's able to initialize it and create this object out of it. And if you don't have MetaMask, then you get an error. That's what this does. It's pretty standard, nothing interesting there really. Cool. And then I'll do a commit for those following along at home. Cool. Okay, so let's collapse that. The next thing we need is blockchain data. So this one is a bit interesting, so I'll talk through it. Right. So load blockchain data. So we've got an instance of Web3 that was initialized earlier on, right? We make a JSON RPC call to get accounts, and then you should just say, and then we'll get the first one from the list. MetaMask and most other wallets only expose one at a time. The network ID should be 31 or 33, depending on what you've connected to, and you can select that in your wallet, such as MetaMask. And what it needs this for is so that it can take a look at the colors JSON file, which you saw earlier on, and inside of it, it will use that to obtain the deployed bytecode for the smart contract, and it will also just take a look at the ABI. The ABI tells it what functions there are. We didn't quite take a look at it earlier on, so let's see if I have that open still. Yes, I do. Okay, still, yes, I do. Okay, so wrong one, sorry. Colors JSON is what we want. Scroll up to the top. We can see that the ABI for the colors thing, it has it has several functions. Let's just see which one. Yeah, so a name returns a string, so that's how we know it's called colors. Let's see one that we recognize. Total supply. That will give us a total number of tokens that comes from OpenZeppelin's ERC 721 implementation. Yep. This one's important. Owner of. Balance of. I'm trying to find our mint one. Symbol returns FARBE, which we configured earlier on. Yeah, and I'm expecting to find it right at the bottom somewhere. Let's see. Yep, there's our mint function right at the bottom. Okay, so sorry, I should have just jumped to that right away, a lot of time. Okay, so used all of that to initialize a contract class from Web3. And then once that has happened, we have the instance of the contract class, and we can call the colors method on it, which essentially obtains its data from here, right? It's an array of bytes 3 variables, and then it can also then what it does is it adds it iterates over it, and keeps appending it to this list within the state of the list of colors. And this colors is what is used to render a list of colors later on. Okay, right. So we're just going to add that function. We've already done that. Sorry, really not. Yep. And commit. Cool. All right. Now we have a mint function. So we've coded a mint function in the smart contract, and now we need to have the equivalent of that in the front end. So this mint function is responsible for calling this mint function inside the smart contract. That's what we're doing. So the same contract that we initialized earlier on, right? This .state.contract object has a bunch of methods, and the method for mint, we're going to send it a color byte. The method for mint, we're going to send it a color bytes, which is passed in from user input. And then when it's successfully completed, we set the state we append to the colors list the new state so that it can be displayed. So yeah, pretty straightforward. Sorry, save that first. Yep, and then I'll do a commit for those following along at home. Push. All right, then the last function is a render function, and essentially it does two things. It displays a form that allows you to input a color and press a mint button that calls this mint function. And the other thing that it does is it displays a list of all colors. Very, very straightforward. I won't be going into the details. We're not really here for a React workshop or tutorial. This is just get the job done, I guess. But essentially, I'll just highlight the parts. This is the form with an input field and a button that allows you to trigger the mint function that we just wrote earlier on above this. And this div over here loops over all of the colors that are stored in state and renders them. Cool. So we've got the render function in, and we can commit it. Okay, now we're finally ready, and I am going to open up a new terminal. So just look at this over here. I've opened up a new terminal, and I'll just blow this up to full size and cd app. Okay, so now I'm in the app folder. Slightly bigger. Okay, so now I'm in the app folder, and I am able to run this command over here. Npm start, and so that runs whatever Bootstrap create React app needs, and then it starts that. So let's see what we have here. You should be able to run localhost 3000, right? And there we go. We have this. Now, for those of you who are doing it for the very first time, you won't jump straight into this. Right? I've done this tutorial before, obviously, while creating it, but what you're expecting to see is something like this, right? MetaMask notification, and basically say the title of your application running on localhost wants to connect to account, whichever account that you have selected over here, right? And it'll say pretty much that, and then you have to press connect. If you press cancel, then this application is not going to work. So it basically requires your permission. MetaMask is saying, hey, I need your permission. Do you trust this website? And I obviously the answer right now is yes, so you just press connect. But if it's someone else's DApp and you're unaware that you're visiting a DApp, then you might want to press cancel. Okay, so now we're going to ensure that we are connected to the RSK testnet, right? Over here, right? RSK testnet. Now, if you don't have that set up, I would strongly encourage you to click on this triple dot ellipses over here. Go to expand view, and then over here, click on custom RPC, and then you can go ahead and create a testnet reference over here, and it should have the following values, right? So on and so forth. I won't be going through this now, because there is another webinar for precisely this. Cool. Okay. Interesting. Yeah. Okay, cool. So issue token. Let's do that. Actually, let's check whether we have testnet RBTC. Yeah, we do. Okay, so we have enough to pay for gas. That's excellent. If you don't have MetaMask set up already, I would strongly encourage you to take this over here, cat.secret, right? And you copy this over here, and then you go to MetaMask, and I'm not sure how to. I've forgotten how to do it. Is there a way to? Aha. So you can do this over here. You can import account, or you can go to settings. Sorry, this is settings. Yeah, but essentially you can create a new account and you can say, hey, I want to use my existing mnemonic, and then that will connect to the same set of wallets that you're using to deploy your smart contracts with. Otherwise, you'll have to do a gas transfer. Okay, where were we? So we got the colors thing. Cool. All right, so I'm gonna pick this color. 6E, 3C, and that should give us some sort of green color. Press mint, and then what happens is you'll get this dialog box pop up, and you can see that, hey, I'm going to be paying 0.00002 amount of gas, right, to perform this transaction. Basically a tiny fraction of an RBTC. What's interesting here, right, is that you can actually look at the data of the smart contract. So this is a long hexadecimal string, and that's sent in the transaction. So right now what you're doing when you press confirm is you're going to be saying, hey, I accept this transaction, right? And I'm going to sign it. And what you're essentially doing is you're sending a transaction where the to address is the to address of your smart contract, right? And the first 4 bytes, or 8, I should say 8 characters in hexadecimal, they identify the function that you're calling. In this case, the mint function. And there is a way to work that out, but I won't be going to that later on. I won't be going to that in this tutorial. And then the next bit is all of these are the parameters, the input parameters that are being sent to the mint function. Now in this case, we only have one parameter of type byte 3. And you can see in this case it happens to map exactly because it is a hexadecimal value, 00633C. Yeah. Anyway, so you got that value over there, and then the rest of the zeros are just padding, right? So basically the smart contract's going to ignore them. Press confirm, and this is going to take a while, right? So you'll click over here and you'll see contract interaction pending. And you'll see that spinner spinning for a while. And what I'm going to do now is I am going to, while we're waiting, is to take a look at, right? So that's the testnet, right? So what I'm getting here is a smart contract address for my thing. And then I'm going to go and jump into the RSK block explorer. And I'm going to just, oh, look at that, my transaction just came through, right? If you didn't see that live. Okay, but we're going to see, hey, I've now got a colors contract. It doesn't have any balance, but it's recognized it as an ERC721, right? Because it complies with certain well-known ERC or EIP standards, right? It was deployed 21 minutes ago. This is the transaction in which it was deployed. So everything is readable. Now, what we want to take a look at, or what's of interest, is accounts. So we're expecting to see one account with 0, which is, I guess, the smart contract itself. And we're going to see another account, which is the account that we just interacted with over here in our application, right? So we're using account 0x4c blah blah. We're going to use that exact same smart contract, that exact same account. We're going to see that over here. So this address now owns one color coin, right? One color non-fungible token, right? Cool. So now what I'm going to do is switch to another account that I happen to have, right? Which is sorry, wrong dialog. This one. I have another account, right? And this one also has some gas, right? Now, if this doesn't have any gas, then you can use the faucet again to transfer to this new account, or you can transfer from your existing account to the account that, you know, I'm not going to do it because I don't need to, but I believe I have the command somewhere here in this tutorial. There you go. So you'll want to do this. And I'm just going to jump back into this. So that command is what you need to enter. Now, this your account address to and your account address from basically need to be two of your own addresses. So, for example, if this is your account 1 and the first account, and this one has some testnet RBTC because you've already used the faucet for it, then this is the other account. So this will be your from address and this will be your to address. So just substitute accordingly within this command and you're good to go. Okay, right. So, oh, I've refreshed it. Cool. So now I'm gonna use this to, let's see, I want hot pink this time. Right. So I'm gonna press mint. Maybe not so hot, undecided. Alright. Alright. This might be more of a purple. We'll see how good my color thing is. So as with before, you're expecting the first 4 bytes or 8 hexadecimal characters to be exactly the same. They match the mint function, and then over here we have AA00AA for the color and the rest padding, just as we saw before. And of course, this amount of gas that we're expending. We press confirm, and we'll see the transaction is pending. All right, this time I'm going to hover my mouse around here, hoping to catch the pop-up value, the pop-up dialog. Let's see if MetaMask has fixed its bug. There was a bug in MetaMask where it ignored the Explorer URL, even though the block Explorer URL, even though it was configured correctly, as seen earlier. So if we take a look at this and then we go to RSK testnet, you can see there's a block Explorer URL configured over here. But in that pop-up over here, if you click on it, it would bring you to Etherscan, not the right one. So let's see, is the transaction still pending? Yes, it is. So that should take about 30 seconds. So I'll quit that. Yeah, it sounds like this transaction. Yep, okay, there we go. Transaction 2 confirmed. View on Etherscan. I wonder where that's going to take us. Yep, that's right. Took us to Etherscan. So this is what MetaMask was supposed to do, right? Use that domain instead. And there we go. We've got a transaction, right? And the to address will bring us back to the same smart contract that we were at earlier on. And then if we go to accounts, we'll see that the smart contract itself has 0 tokens. And ooh, what's this guy? Okay, the rendering looks a little bit funny, but yeah, this second address of mine, it 0xA05D, which matches this, right, has the other token. So this smart contract has 2 tokens now. And for those of you following along, this is not just something that's running locally on my computer. You can go ahead and click on this link that I just put in the chat, and you can interact with the smart contract. Now, for those of you who've been following along, right, using Git, meaning that you have the exact same colors.json file over here, right? That means that you can, and you've done the, let's see, did I remember to push? I'll just push anyway. Probably did push, but I'm just doing it just in case. So if you do a git pull and then you just go into cd app and npm start, you'll have the same thing. And if you have all of your MetaMask and RSK networks configured and all that, you can actually interact with the same smart contract, and I will encourage you to do that, right? Because your ABI, your smart contract address, if you followed along, should be pointing to this exact same address that I have earlier on, right? And if that's the case, when you run your application, you'll actually be talking to my application, and you should see my colors, that these exact same ones following along. So you can see, even though I have the the smart contract and the front end within the same code base, if you will. So if I can do a very simple thing like change the smart contract address, and so long as the ABI is the same, application binary interface is the same, it'll just connect to a completely different backend. And that's like, I guess a bit radical, if you will. It's like almost like every single backend is federated and follows the exact same protocol. Which is kind of crazy, because like doing that in the centralized world of backend development is very, very, very hard to pull off. Okay, and I think that actually does bring us to the end of today's tutorial. I hope you've managed to follow along, and if you have any questions, please go check it out on Developers Portal. It's just been published, so it's live now. So the first part one that Sol has just posted the links for is to do the initial setup, and we went through that today. And then part 2 is for the specific one where we create the colors decentralized app that you just saw. Okay, what are we doing next? Yes, I wanted to finish up with slides. Okay. Just got 11 minutes left, so I'll try to go through this quickly. Truffle is an all-in-one tool used for smart contract development, and it plays very well with both Ethereum, which it was originally developed for, as well as RSK. Now, you might be wondering how come it works, and this is ensured, this compatibility, if you will, is made possible because RSK has a goal, if you will, to be compatible with the Ethereum virtual machine. So RVM implements the same opcodes and executes them in the same way as EVM, right? So the virtual machine is compatible at that level. And the other thing is that the JSON RPC, which is the way that any node wants to connect to another, where any internode communications, if you will, want to connect to each other, they do so via this standardized remote procedure call interface. And RSK implements the exact same one as Ethereum. And because we have these two things as compatible, pretty much all the tools just work. So Truffle is an example. Web3.js, which we also used, is another example. MetaMask wallet, Nifty wallet, also other great examples. And another interesting thing about this is that whatever DApp you develop and runs against RSK, for example, the one that we just developed, if for example, what we could do is go back to Truffle config. Let's see, where's Truffle config? Over here, right? And we could quite easily just define a new network here for Ethereum, right? Whatever, and we could just compile and deploy the same smart contract, and run the same app against Ethereum as well. It's as simple as that. The compatibility level is pretty amazing. All right, So one of the key parts of any decentralized app is a smart contract. Now these are bits of code that are deployed to the blockchain. Now what actually gets stored on blockchain is two things: executable code and data. The executable code that's stored on the blocks in the data on the blockchain is immutable, meaning once it's there, it can't be changed. And that gives you a whole bunch of guarantees about how a program can execute that you don't necessarily get or you can't be sure of in existing centralized solutions for centralized backend solutions. Now, the data that is written to the blockchain that's part of the smart contract is actually mutable, but it has like a little bit of an asterisk in it. Any data that's mutated, right? The transaction in which it is mutated, it can only ever be done by the rules that are encoded within this immutable code that's inside the smart contract. So it leaves an audit trail for every single thing that it does, right? So even though it's mutable, you know exactly how it was changed. And compare that to a centralized solution where you just have a backend with a database, say it's Postgres or whatever. A database admin could just arbitrarily log in because they have the access rights and change the data. And there wouldn't necessarily be an audit trail that you as the end user would have access to and be able to audit or verify. So that's what makes applications or decentralized applications different, in the sense that you can be very sure, you can have all these guarantees about how the backend actually works. All right, next up we have signed transactions. So each time you execute code inside of a smart contract, this potentially modifies data, right? So that means that anyone who's running an RSK node, whom we refer to as miners, they incur a computational cost as well as a storage cost. So this needs to be paid for, and we saw earlier on, each time we did a transaction, a tiny fraction of our BTC was deducted from our account balances, and that was payment in compensation for executing the code, paying for the computation and storage. We also made use of OpenZeppelin today. It's a smart contract library full of Solidity code, and these they provide for many different common use cases. So the one that we looked at today was non-fungible tokens. We also used OpenZeppelin's ERC20 implementation a couple of weeks ago for our smart contract tutorial. Our fungible token tutorial. And yeah, the main thing about them is that they're audited, so you can just use the code with a lot more confidence than if you were to, say, take a look at the ERC 721 standard on your own and try and implement it from scratch. That is almost certainly not a good idea. All right, and what is a non-fungible token? I sort of talked about this a little bit earlier on. Each token is unique, and minting restrictions are what give them rarity. So the example that we had today, it enforced a particular rule such that if a color already existed, you can't mint the same token, the same color again. So if I had AA00AA, that pink color, right, no one else can get that exact same with pink. So when something is rare, then it becomes collectible, right? If enough people are interested in it, I suppose, and if, like for example, in the case of CryptoKitties, if they're cute enough as well, right? So CryptoKitties is a non-fungible token as far as smart contract is concerned, but the front end for it displayed very cute graphics of cats, and people decided that they were worth a lot of money because of that, and because the backend backed it up, the smart contracts backed it up by ensuring rarity encoded inside of these immutable smart contract code. They actually became a collectible item. Okay, and the other thing is that they're transferable from one account to the other. So this particular smart contract that we had, it inherits from ERC 721 from OpenZeppelin, which has a transfer function built in. So one can actually say, hey, I want to transfer my this non-fungible token with this ID from myself to this other account. Yeah. What else? Duplication. So a non-fungible token is not possible to duplicate. So the way the underlying OpenZeppelin implementation does it is that it has an incrementing ID for each token. So each token, and that ID is a unique number. So no two accounts can hold NFTs that have the exact same ID number, and that's what makes it impossible to duplicate. Okay, so if we have any more questions, we're happy to take them. At this email address, developers@iovlabs.org. Otherwise, there is another channel in which you can do so. You can go to the RSK developers portal. So this is our great, like a great resource for information on how to get started using RSK as well as developing for it. The tutorial that was linked by Saul earlier on, you can find them over here. So this particular one should be here. Oh, sorry. It was published during this webinar. Okay. But what I wanted to show you is that we also have this open chat button that you see in the corner, and that will bring you to Gitter. So this is a public chat room open to anyone. You just need to sign in with GitHub or Twitter, and you can do so. The URL for that is this. I'll just paste that in the chat. Yep. Okay, we've got 2 minutes on the clock, so better wrap it up. Okay, so yeah, just on time. Thank you very much, everybody, for coming to today's webinar. I hope this has been useful, and good luck with your journey to becoming a blockchain developer on RSK. Thanks.